Okay, so picking up where we left off from the last vid, the graph of f of x equals cosine x. Okay, so here we're going to take cosine of x where x is represented by an angle in radians. Okay, all right, so this one's a little bit different, you'll notice from the previous table, because now it's pi over 3 and 2 pi over 3, etc. So, and the reason being is because, if you'll recall, when we took cosine of pi over 3, that's where we got 1/2. Okay, so the other radian measurements that the special radian measurements we used, not as friendly, because square root of 2, square root of 3, that sort of thing. So, we're going to use the 1/2. Now, at each one of our pi over 3's, the value is 1/2. What is in question, is it positive or negative? Okay. All right, so we just have to remember that cosine is positive in the first and fourth and negative in the second and third. So positive, negative, negative, positive. Okay, and as we're going the opposite direction, positive, negative, negative, positive. All right, so cosine of 0, as you'll recall, on our 2-unit measure that we had at 0, our coordinate was negative 2, 0. That was our x, that was our y. So since cosine is x over r, that's don't know why I wrote negative. I know it's positive. Okay, so positive 2 is 0. And then, so since it's x over r, that'd be 2 over 2, which is 1. Okay, we're going to see similarly over at pi, it'll be negative 1. Okay, and then at 2 pi, we're back to 1 again. Okay, so going in the opposite direction, right? At negative pi, it's still going to be negative 1, and at negative 2 pi, it will be 1. Okay, so you might have already guessed, at pi over 2, it's going to be 0. And at 3 pi over 2, it's going to be 0. And negative pi over 2, and negative 3 pi over 2. Okay. All right, so let's see what this looks like on the graph. So if we plot our points, and I'm just going to start out, negative 2 pi was 1. Right. And we saw that negative 3 pi over 2 was 0. I'm just going to hit my zeros first because I've got those already marked. Negative pi was negative 1. Negative pi over 2 was 0. 0 was 1. Pi over 2 was 0. Pi was negative 1. 3 pi over 2 was 0. And 2 pi was 1. Okay, and then if we fill in our pi over 3, at pi over 3 we were 1/2. At 2 pi over 3 we were negative 1/2. Okay, and then there's 5 pi over 6. Again, we're counting by pi over 6, so that's 6 pi over 6, 7 pi over 6, 8 pi over 6, which is 4 pi over 3. Okay, and that was also negative 1/2. Okay, and then 4 pi over 3, and I just noticed we're counting every 2 for pi over 3, right? So that's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, so this would be 5 pi over 3. Okay, and at 5 pi over 3 we were at positive 1/2. Okay, and then going in the other direction, right, at negative pi over 3. Okay, and then 2 more would be negative 2 pi over 3. And 2 more is pi. And then 2 more is negative 4 pi over 3. And 2 more is negative 5 pi over 3. Okay, and we see the same pattern. We're coming down 1/2, 0, negative 1/2, negative 1, 1/2, 0, positive 1/2. Okay, so as we're sketching this, remember it's a wave, it's a nice curve. So we're going to come down, we're going to come back up. Okay, and one of the reasons we have calculators is because I think people like me can't graph well. Okay, now when as we go over the next page where there's some questions, it says on your calculator enter y1. Okay, again, we're not going to do y1. If you'll press tab and you'll do the up arrow, right, we're going to just change this sine of x to cosine of x. Okay, kept the settings on my calculator, so I have the same window setting as my graph, and we can see that cosine is also periodic, and the period is how long it takes to complete one full cycle. So if we start here at 0, we come down and come back up at 2 pi. So that's one complete cycle, and then we see the same one complete cycle from negative 2 pi to 0. So we would say that the period is 2 pi. 2 pi. All right, the maximum value of f of x is still 1, because that's as high as it goes. The minimum is still negative 1. Okay. And where does it reach its maximum? Well, let's go back. Okay. It reached 1 at 0, and at 2 pi, and at negative 2 pi. So at 0, 1, 2 pi, 1, and negative 2 pi, 1. It reaches its minimum at pi and negative pi. Double check that. Okay, negative 1 at pi, negative 1 at negative pi. Okay. The domain we have set for this is from negative 2 pi, to 2 pi. And the range is also from negative 1 to positive 1. The x-intercepts, where is it crossing the x-axis? Well, we can see it does it in 1, 2, 3, 4 places. And those were pi over 2, (3 pi over 2), negative pi over 2, and negative 3 pi over 2. The y-intercept is 0, 1. F of x equals cosine x is an even or odd function. Okay, well, we said earlier, even functions would have axis symmetry, and odd functions would have origin symmetry. I think it's pretty plain to see that if we folded right here down the middle, these two would be mirror images, so it has that symmetry, so this would be an even function. And we can also say it's an even function if f of x equals f of negative x. Okay. In other words, pi over 2 is 0, negative pi over 2 is 0. So that's where f of x, 0 and 0, is equal to f of negative x. Okay. All right. The graphs of f of x equals sine x and f of x equals cosine x are called sinusoidal functions. Just a word we need to be aware of. All right. I'm going to go ahead and stop this video here. So the third video and final video, hopefully, will be our tangent function.